So now we're going to discuss about the digital logic gates. So logic gates are basically the building blocks of any digital system. As we have seen in the slide chart, there are some gates called OR gate, AND, NOT gate, NOR gate, NAND gate, exclusive OR and exclusive NOR. Okay, so these are actually representation of signals and sequence of digital circuit which can be utilized by some numbers of logic. These logic numbers are developed by truth tables, which we are going to discuss one by one. Okay, now the important concept is known as universal logic gate. Universal logic gate is some gates which can be implemented by Boolean function without use of any other gate. So the NAND and NOR gate. The NAND and NOR gates are known as the universal logic gate, which can be implemented by Boolean function without any use of other gates. Okay, so let's proceed to the truth tables. So NOT gate. The definition of NOT gate is that it always gives the inverted output. The inverted means if input is 0, then output will be 1, and if input is 1, then output will be 0. Therefore, the NOT gate is also known as inverter. Now, the symbol. The NOT gate symbol is like this: the single input and single output. Now, the logic equation of NOT gate is that y equals to a complement. Otherwise, y equal to NOT of a. Now, the truth table of NOT gate. As we have seen that here only one input a and one output y, and possible combination of input is 0 and 1, and if input is 0 then output will be 1, and if input is 1 then output will be 0. Let's come for OR gate. Its symbol is look like this, where a and b are two inputs and y is output. Input can be more than 2, but output should be 1. And what its definition says, if one input is high then output will be high. That means either a or b input is high then output will be high. Then logic operation, it says y equal a plus b. Simply plus is for OR operation. Next come for truth table. Here what happen, if both the input is low, that means a and b are 0, then output will be 0 because no high input is available here. Next, what we have seen, the a input is 0 and b is 1, that means b is high. From the definition we have seen that if one input is high then output will be high. That means here a is low and b is high and output will be high. Therefore y is equal to 1. Next, a is 1, that means a input is high and b is 0, b is low. And if we have one high input then output will be 1. Therefore y is equal to 1. At the last part we have seen the both the input is high, that means a is 1 and b is also 1, so the output will be 1 because here two inputs are 1. Now the AND gate. The definition of AND gate is that the output is high when all the inputs are high. That means if both the inputs are high then we will get the high output, that is 1. Now the symbol of AND gate. The symbol of AND gate is look like this, where two input a and b and one output y. The input can be more than 1, more than 2, but output should be 1. Now come for logic equation. So logic equation of AND gate is simply y equal a dot p, where dot represents AND operation. We can simply write y equal to a and p. So now truth table, here 2 inputs and 1 output, a and b. So combinations are 0 0 0 1 1 0 1 1. See here both the inputs are 0 0, that means low, so output will be 0, because our condition was that the output is high only when the inputs are high. Second and third case, the one input is high and one input is low, but both are not high, therefore the output is 0. But for last case, both the inputs are high, that means 1 and 1, and according to our condition, if both the inputs are high, then output will be high, therefore the y is becomes 1.